With no further ado, let me introduce our first speaker. I'll read the bio for each speaker as they come up. Actually, there's two folks that are going to come up. Ralph's going to come up with IBT, and I'm going to read your bio, Ralph, even though it's brief. You told me not to. I'm going to do it anyway because it's a lot of good things here, Ralph. So, Ralph Andrews is president of Integrating Building Technologies with over 40 years of experience in the mechanical contracting and controls industry. Ralph Andrews is the president of Integrating Building Technologies. Ralph's leadership allows integrated building technologies to create intelligent buildings and optimize building performance. His areas of expertise cover all phases of HVAC, controls, and building analytics. In addition, Ralph will be bringing up Keith LaRose. Keith is Director of Business Development for CopperTree Analytics. With 14 years of business development experience in software, scientific, and environmental verticals, plus a background that includes environmental monitoring and renewable energy projects, Keith now leads the business development charge at CopperTree Analytics. At CopperTree, he focuses on energy management, automated fault detection, and diagnostics software solutions for companies who want to create operational efficiencies that reduce their building's energy consumption and enhance their bottom line. Keith holds a diploma in network engineering from CDI College, as well as a diploma in business management and advanced technology from Simon Fraser University. So please welcome Ralph and Keith.
Good morning, everyone. Thanks for coming out today. Our first presentation, Integrated Building Technologies. We basically are offering direct client BMS controls and building analytics solutions to direct clients. We work with building managers, building owners, and end users. We offer full BMS systems. We are a part of, many of you in New York might have heard of BP Mechanical or BP Air Conditioning. BP has diversified into the BP Group, and we are one of the arms of the BP Group. We have two product offerings. One is Delta Controls, which is full building automation systems, controls, retrofits, design, engineering for direct clients. And the other product, which and company that we're associated with, is CopperTree Analytics, which we're real excited about. It's basically building information. So without delaying any further, I'd like to introduce Keith LaRose, who's going to speak on CopperTree. Thanks.
Hello, everyone. Thank you, Ralph. Okay, so the title of my presentation, Smart Buildings Have Promised a Lot. So just get a feel for the room. Hands up if you know what a building automation system is. All right, that's great. Okay, that helps a lot. So I'll go through a bit of a story. I'm going to tell you a little bit of how the technology works and what it's all about, and then we can have some questions at the end, I think. So first of all, I wanted to talk about an energy management system and what that looks like and what a good energy management system can do for you. So I'll talk about that, and then we'll add in a bit more of the pieces to talk about fault detection and diagnostics. So a good energy management system should be able to give building owners and operators a breakdown view of their energy usage, whether that's electricity, steam, gas, water, etc. It should be able to give you that breakdown over time. It should be able to give you sort of daily views like this, where you see your energy use over a period of the day. You should be able to, in real time, alarm a condition where you have a baseline being exceeded, where you have a condition that is outside of a norm, for instance. If you're running things at night that shouldn't be, an energy management system should be able to identify that for you. A lot of times, currently, people are waiting for the end of the month for the utility bill to arrive and getting surprised by the energy that's gone up. So having a platform that allows you to see this in real time at 15-minute increments is very powerful. So this is some examples of some of the tools that we have here at CopperTree. And we're a cloud-based data analytics company that does energy management as well. So this is a breakdown consumption view for a month of energy usage. And you could sort of organize this however you'd like. One of the things I'll point out with these types of energy management solutions is that we are using what we call virtual metering. So we're able to take sensor data that exists already in your building and turn that into energy meters. So you no longer have to, you should always have a couple of energy meters in your building, certainly, but we can put an energy meter on every single HVAC piece of equipment in your building, either on air side, water side, or electricity. So we do calculations like delta T and flow, and we're able to calculate a BTU usage in real time on every box in your building. So that really gives you a very granular way of looking at energy. So, reporting is a very important part of an energy management system. So you should be able to have some very sophisticated reports that come out. There's a cumulative energy consumption table here that we're looking at. But what I'm really here to say today is that that's not enough. So everyone has a building energy management system, I would assume, or hopefully you do. But that's really not enough anymore. What we're here to talk about today is analytics and actually using that big data to transform the way you're operating the building. And so analytics, just so we're clear on what that means, it's taking big sets of data and turning it into information. So it's taking a sea of data, and everything that we have in our buildings is creating data these days. You have temperature sensors, you have speed drives, you have set points, you have all kinds of things that the BMS already in your building has. So we're not having to invest capital to capture this data and to use it. So we're a cloud-based big data analytics solution. And why analytics? Let's talk through that a little bit. I'm going to give you a couple of case studies. The first one is looking at the Lakes Crossing Center in the state of Nevada. So it's a government-owned maximum security psychiatric hospital. So pretty interesting building there. The challenge they had is a lot of peak demand charges in Nevada. And of course, hot weather is sometimes difficult to predict the peaks in the energy that were happening inside this building. So the question was, could analytics help to predict those peaks and to solve that problem? So what we were able to do with this using Powerful Analytics solution is to take the historic consumption of a building, and we also tap directly into the NOAA servers on the cloud, so everything's cloud-based, and we bring in a weather history of that particular zip code, and we then do a regression analysis of the weather history to the energy use in the building. And what that gives us is a nice model to predict the next 24 hours, because NOAA also gives us forecasted weather. Whether or not they're accurate, that's a different question. Sometimes they're not. But that's as good as we can do as far as analytics goes. Bringing in history, doing regression, predicting tomorrow's energy consumption, and being able to pinpoint where the peak's going to occur in the next 24 hours. So that's really what we're talking about here in this particular case. Now, going a step beyond that, we are integrated directly into their building automation system so that the system can make a decision by itself as far as how it can limit the demand in the building. So we have a number of demand response sequences pre-programmed in the BMS, phase 1, phase 2, phase 3, let's say, where, for instance, if we see a peak is going to occur in demand between noon and 1 o'clock, we can pre-cool the building. We'll identify the peak is going to occur at that time. We'll pre-cool the building ahead of time and then shut the chillers off to ride out that period during the peak. So that really gives us, and that's all happening automatically. So we're reading the weather data, looking at the regressed energy, predicting the energy consumption, and then changing the control system accordingly for that day without any operator intervention. So it's a really amazing technology if you think about it. Here's an example of one of the reports that we generate out of this. This is the raw data that we're looking at, where we're looking at the building power, which is a real-time measurement, the building power baseline, which is the previous to us being involved in the project. You can see the peak being set here on the dashed blue line above 100 kilowatts. In this particular building isn't a very large one, but in this particular case, forecasted power and the forecasted power baseline. You can see the forecasted power and the actual power consumption follow each other fairly closely, and that the overall peak of the building is being reduced substantially using this. So what that really means from the ROI perspective in this particular case is on this one building, and we're working with a lot of buildings with them, we were able to reduce the peak demand, and this is only a 35,000 square foot facility. It's not too large in this particular building. So we're able to reduce that peak demand by 5 kilowatts, which is a savings of about $35,000 a year for them. We also found some average energy consumption savings using our tool as well. The portion of our tool that does this analysis for them has a cost of about $1,200 a year. So we're looking at a pretty big substantial ROI there for these guys. So that's one particular case study. Let's talk about beyond energy analytics, and let's start talking about fault detection and diagnostics. And one of the problems with an energy management system and metering is that it's really a symptomatic approach. So you're waiting for something breaks and then you get an energy increase, or something's left on and you see an energy increase. It's a lagging indicator. What we really like to do is use fault detection and diagnostics to actually pinpoint where the issue is in the building. So I refer to it as basically saying energy analytics tells you your house is on fire, but fault detection and diagnostics tells you what room the fire started in and how it started. So you can either go shut it off or prevent it from happening the next time. So that's really what fault detection and diagnostics can do. It's a grounds up approach looking at the underlying systems in the building. So let's talk through a couple of things on fault detection. So fault detection and diagnostics, one of the problems with an energy baseline, a lot of people manage their energy to their baseline, and that's a problem because your baseline probably contains a lot of inherent errors. You probably got baseline that includes things that shouldn't be running, but you're comparing yourself to that. You're saying, wow, we're doing really great. We're managing our baseline. We're staying below our baseline. But there's probably some things underneath that baseline that are quite wrong in every building. Another thing we look to do with fault detection is to improve tenant comfort. That's very big for a lot of people. In fact, sometimes more important than energy efficiencies, depending on what business you're in. So I'll talk to that a little bit as well, and how we can use fault detection to improve tenant comfort and to improve the dollar per square foot maintenance cost. So this new technology really allows you to drive efficiencies in the maintenance of your buildings. So those are the goals of an FDD system. And let's talk about what people say, oh, I've got a BMS already. I get alarms from my BMS. I don't need fault detection. I don't understand what the difference is. So the difference between an alarm and a fault would be that an alarm will tell you if your supply air temperature is outside of a range that it's supposed to be. You say, I want my air temperature here, and if it goes outside that range, sure, your system will tell you. The difference between that and a fault is the fault could be that you have an incorrect air setting and you've got a set point that's too low, and your zone systems are actually reheating cooled air. So you're cooling air and then reheating it in the zones. Happens all the time. Sounds silly, but that is a problem that we see quite a bit. And that's a very expensive problem, let's put it that way, because not only are you overcooling, you're then heating again in the zones to maintain set points. The worst part of this is that your tenants won't complain because the zone temperatures are right. They're comfortable, they're happy, but your energy is being used very inefficiently. So that's an example of what a fault is versus an alarm. I'll give you another example. You might have a leaking air damper on a system. That's also a very expensive problem if you're bringing outside air in. The goal of a system would be to recirculate preconditioned air, bring in the minimum required air to maintain fresh air inside the building, and reuse the cooled air or the heated air that you've already got inside. If you have an outside air damper that's stuck open or leaking, you're bringing outside air that in New York is quite cold in the winter and other places are quite hot in the summer, and you're having to recondition this air. So by having a couple of sensors that we already have in the BMS, we have a mixed air temperature and we have a return air temperature. Those two temperatures, if the damper is closed, are supposed to be a certain distance apart. And if they're more than a certain distance apart from each other for longer than a certain period of time, then we know that that damper is leaking, for instance. So there's a few things like that. We have a couple of hundred different examples of fault detection rules that we put in place in buildings when we go in to do a project. Give you an example of one of these particular projects we worked on. This is Seattle University. And so you can see the breakdown electrical consumption of their VAVs on a particular area in their buildings. You can see that 2 of the VAV zones are actually consuming 25% of the energy of all those VAVs. So this is easy to find. We just put our system in and said, hey, how come these 2 VAVs are using all your energy? Normally people don't meter VAVs individually. So we did B2 metering on all of their, and electrical metering on all their VAVs using virtual metering, which would be quite cost prohibitive otherwise. What we found from that is that those 2 VAVs were actually consuming way too much energy. They're fighting each other. One was a cooling area and the other one was heating. They were maintaining space temperatures, battling each other the whole time, and reheating and cooling. So after implementing some resequencings in this particular building, we're able to save $8,200 approximately, with the annual cost for the tool at about $1,400. So again, these are just small examples of one zone at a time where we're making big differences to people's businesses. One of the things we find is you might invest in a building recommissioning. You might come in and spend a whole bunch of money recommissioning the building, installing new controls and doing everything. If you came back to that building 3 or 4 months from the day you left, what will the building look like? Will it still be in the condition that you left it? And the odds are that it won't be. There's all kinds of things happening day to day. People are busy, they get a complaint, they put something in manual, they change a set point, they change a schedule, and they forget to put it back. And that happens all the time. So what we have is basically an inability to maintain the design and the efficiencies that are designed into a building. So you can have the smartest building in the world, but if you put it all in manual and you operate it that way, it's not an efficient building at all. A lot of times in the LEED program, you have a LEED Platinum certification, hang that plaque on the wall, and you only come back to it every time you have to recertify for LEED. And that happens all the time as well. So what we're presenting here is a typical solution, which would be you could go around if you had 5,000 people working on it. You can go and look at every point every day, make sure everything hasn't changed. Most BMS systems, they won't tell you when things change. That's one of the issues with them. What we have is something that we call the golden standard. And that golden standard monitors every change to the automation system that's created from the time the system's installed. So we're an ongoing commissioning, which we can create a baseline of the configuration of the automation system in a building. So the first day we set this up, and believe it or not, there's actually zero programming involved in this. We plug in a small box at the building. It starts sending data to a cloud server. It sends every setting in the building, every BACnet object property gets read, stored as a baseline, and sent to the cloud. And then every day at midnight, we check again. We say, hey, what are all the settings in the automation system? And any differences are flagged. So what that you end up with there is, for instance, this is a list of insights, we call them in our tool, that are identifying changes that have happened to the settings in the control system, including schedule changes, things that are uncommissioned, program data being changed, things being put in manual. If you were to zoom into one of these, it gives you the detail of what property in this object. In this particular case is a chilled water valve, and it's an analog output, so it's a chilled water valve position. And when we took the snapshot, which in this case was August 27th, 2015, it was not in manual, and then as of September 8th, 2015, it was a manual overridden to 100%. So someone's overridden the chilled water valve to 100% in this building. And you may or may not remember to put it back. So you might have a chilled water valve that's open at 100% for 5 years before you realize that it's in this condition. There's nothing that's going to tell you about this. So this being said, you can then identify the change easily, and you can choose to promote it, if you choose to do that, into the baseline of the building. So the baseline is really a living, breathing, ongoing baseline. You can make the changes, you can accept them and continue on your day, or you can go and revert them back to the way they're supposed to be. So an ongoing commissioning tool is very important. Here's a report, for instance, we call the Golden Standard Digest. And it's all of the changes that have happened in a building automation system in a certain period of time. And this works on any building automation system that is standard protocol. So very valuable for an operator. To give you an idea what this means is if you were to put something in manual, for instance, in this particular case, we have a schedule here. The green sawtooth is a schedule. I'm occupied, I'm not occupied. You can see the electricity consumption is following that pretty nicely until the day that someone puts something in manual. And if you didn't have either a really good energy management system that alerts you to this and or a tool like ours to be able to say, hey, this thing's in manual, you're going to consume energy throughout the nights in this particular case, and that's going to cost you a whole bunch of money. This could be happening in hundreds of places in your buildings right now. So let's look at a quick little example of this. We have a customer, they're a hospital, and it's I'm from Canada, and this particular hospital is in Canada. It's quite cold there. During the winter, they have a system that looks for the outside air temperature and says, how cold are you outside? And if you're approaching freezing, we're going to turn the heating on the helipad so that the helicopter doesn't slip off and when it's landing. So this particular sensor was left, the input was left in manual, and it was heating all summer. So they basically ended up with a very costly small mistake that cost them, about $17,600 to heat that helipad during the summer. So that's one example of that would have easily been caught. In fact, we didn't catch this one until after we started working with them. So that is something to keep in mind. Let's talk about preventative maintenance and some of the challenges in maintaining buildings. So a lot of people do rotational preventative maintenance. That's what they do right now. I'll give you an example of some of what we use is called key performance indicators, KPIs. What we can do there is I'll give you what that looks like is we have a set point for, let's say, a zone temperature, and we want to see how well each zone in our buildings perform. You maybe have 500 zones or 1,000 zones in a building. I have a set point, which is the solid green line, and then I have an acceptable dead band above and below that. Let's call that 1.5 degrees above and below 71 degrees, let's say. I'm okay with that temperature, but I don't want it to be outside of this range. This is a comfort issue. It also could be an energy issue, depending on my system. I measure the number of minutes that I'm spending each day between 6 a.m. and 6 p.m., if that's my occupied period, within the range that I find acceptable. And I total all that up into a percentage, and I can basically rank the performance of every single zone in my building. And that's all being done in real time all the time, on thousands of zones if I choose. So what we get from that is we get a report that identifies, first of all, the overall comfort index for the building. In this particular case, this is the State Library and Archives in the state government of Nevada as well. So 48% of the zones were maintaining their set points in a mode that we'd find acceptable before an improvement program. And we identify the best and worst performing zones. What you can do is target the worst performing zones for service and maintenance. And you ignore the best performing zones because why would you focus on those? But right now, the way people are doing their maintenance typically is they just grab a batch of them and they look at them all. And they find the ones that are broken within that batch. And meantime, these other ones over here are performing very poorly. So what we'd focus on is always improving the worst performing zones. So after this is actual case study, a month later, we were able to improve the average performance of the zone systems in the state archives to 79% of the zones to be within 1.5 degrees of their set point. We did that by only focusing on the worst performing zones. So just to give you an idea of the kind of ROI that we can talk about there is traditionally you would inspect, let's say, a third of your systems a year, of which you'd fix 10%. So you'd end up looking at, like, say, 30 out of 1,000 VAVs you'd actually repair, and you'd spend the labor to look at every single box. What we would do is rank and monitor the performance of all 1,000 boxes, target the maintenance only at the worst performing systems, and for the same amount of labor, you can actually fix 100 systems where you would fix 30 previously and still save money on the labor. So that labor can be retargeted elsewhere. We're not saying we're going to not have people working there. It's just they're going to be working more intelligently with data as opposed to just doing things, painting the bridge from one side and starting over again. So that's sort of an ROI thing. A couple things to talk about selecting an energy management or fault detection diagnostics system. Make sure the system you're looking at has the ability to scale up and down and includes the features that you're looking for. All too often we see people that go and buy an energy management system and they have a BMS already. Those two don't integrate, and then they buy a fault detection system over here. Now they have 5 screens in front of them in their control center. And that's really not a good way to operate. So think about looking for a tool that would have everything integrated into one, from the building control, energy management, and fault detection all built into one tool. They do exist. We have one. If you'd like more information on it, please do talk to us and IBT here. And then I'd also say start with a pilot project. There's no need to invest in your entire portfolio, although if you would like to do that, we'd be happy to help you. But if we want to do a pilot project, we're typically looking at, we can do a pilot in the neighborhood of about $10,000 on a portion of a building, show you ROI, show you return. And we've never had a pilot that wasn't successfully cash flow positive in the first 1 to 2 years. So yeah, I guess that's pretty much all I had, and I'll open it up for questions if there are any. Go ahead. Oh, I think she's going to run the mic over.
Based on, thank you very much. Mm-hmm. Your presentation has been based on showing analytics from a electromechanical performance standpoint, mm-hmm. where you're putting sensors and monitoring existing systems. However, amongst the group of building owners and building managers, you'd also have architects and engineers. You haven't addressed what would be recommendations for, say, insulation or facade design, changes in fenestration, infiltration, windows, doors, things of that nature that would also have a marked impact upon the heat gain or energy consumption in the spaces.
Correct. Typically, we don't do a lot of building envelope analytics, although we can M&V changes after they're made. As far as modeling what an R factor change would make on a particular building's energy consumption, that's really not our sort of niche, but we do, for the sort of predictive analytics, we do have the ability to import performance models of equipment, for instance. So if you were considering to do, a variable speed pump upgrade to constant volume pumps, we can import in the performance curve of the new pump, for instance, and then we can analyze what the ROI would be on that change compared to what you have existing. But that's more on the mechanical. You're right, it's more on the mechanical electrical side. On the building envelope enclosure type of thing, we don't typically get involved in that. That's more, there's modeling tools that an engineer would use for those. But we do have the ability to import time value pair data into our system as trends, which aren't really trends. They're actually created from whatever the model is you're using. So you can import those and then use those in your analysis, but not so much on the envelope side. Mm-hmm.